Hi, welcome to MACSGATE. Hope you are enjoying DBMS classes. As a part of DBMS subject, we are discussing normalization concept. Under normalization concept, in the last session, we have started the properties of decomposition. So, in the last session, we completed the first property, which is lossless property. In this session, we are going to discuss the second property, which is dependency preserving. So let us continue the session. Properties of the decomposition. What are the properties of decomposition, sir? The first property is lossless. This we completed in the last session. And the second property, which we are going to discuss today, is dependency preserving. These are the two properties of decomposition. Let us make a quick revision of the first property, lossless property. Suppose I have a relation R which was divided into two relations. Suppose R1 is the first relation and R2 is the second relation. Then how to verify whether the decomposition is lossless or not? For that, the simple point is I need to verify R1 intersection R2 is a key either for R1 or for R2. What is the meaning of R1 intersection R2, sir? This is the set of common attributes for both of relations. So we need to consider the common attributes for the relations, and we need to verify whether the common attributes is a key for R1 or R2. Fine. So this is what we have completed. Now in this session we are going to discuss the second property, which is dependency preserving. Let us continue it. Dependency preserving. What is the rule or what is the condition to verify whether the decomposition is a dependency preserving or not? Suppose R is the relation and F is the set of valid FDs. F is the set of all valid FDs on the relation R. So this is our assumption. Let us assume R has divided into two relations, R1, R2. So R is divided into two relations, R1, R2. Then what we supposed to verify? For that, first I need to divide F into two parts. F into two parts. The first one is F1, the second one is F2. What is the meaning of F1? This should consist of the attributes. F1 is the set of all FDs, which consists of only attributes of R1. That means we need to consider all the valid FDs, which is having only the attributes of R1. Similarly, what is F2, sir? It will consider all the FDs on R2. Actually, in this case, instead of considering F, we generally consider closure of F, because it will contain all the valid FDs on the given relation. So when we want to divide F into F1, F2, instead of considering F, generally we consider the closure of F, that is F plus, right? Then suppose we are ready with F1, F2. What we supposed to verify for dependency preserving? The condition is F1 union F2 closure is equal to F closure. That means I need to verify these two sets are equal or not. Anyway, to verify this one, the first one is trivially happens, sir. That is F1 union F2 is subset of F plus. Why it's so? Because F1, F2 were generated from F closure only. So surely the union will be in the F closure. Now the main step. What is the main step, sir? I don't know whether F closure is contained in F1 union F2. Sir, our intention is F closure contained in F1 union F2. What does that mean? We need to verify whether F1 union F2 covers the given F. F1 union F2 covers F. So this is the condition we need to verify. Actually, or basically the condition is F1 union F2 closure equal to F closure. For that, it is enough to verify only this condition, that is F1 union F2 covers F or not, right? So this is dependency preserving property. Then what is the procedure to verify the decomposition is dependency preserving or not? So let me give the procedure first. So as we said, suppose R is the relation. Then the second one is F is the set of FDs. What is the first step? We need to find F closure. We need to find F closure. What is F plus? That is closure of F. The second step, I need to divide or I need to separate the FDs of F plus into two parts, F1 comma F2. So we need to form F1 comma F2. What is the third step, sir? Find F1 union F2. Find F1 union F2, right? Then what is the fourth step? We need to verify F1 union F2 covers F. Actually, here we need to verify whether it covers F closure. But whenever this covers F, automatically it will cover the closure also. So that's why we consider only F1 union F2 covers F or not. So these are the four steps we need to consider this one. And we have already discussed the procedure, how to cover it. So whenever we are discussing the concept of equivalence, we have already discussed what is the meaning of G covers F. What is the meaning of G covers F, sir? We need to assume the FDs in G. Then I need to verify all the FDs of F were implied by G or not. That means first we need to assume them. Then we need to prove them. Right? So this is the procedure. Let me explain the procedure with one example. Suppose R is a relation with 5 attributes A, B, C, D, E, and the FDs are A implies BC, CD implies E, B implies D, E implies D. So we have 4 FDs and the relation is decomposed into R1, which is having 4 attributes A, B, C, E, and R2, which is having 2 attributes, one is B, one is D. So now we need to verify whether this decomposition is satisfying dependency preserving or not. What is the first step, sir? The first step is we need to verify the closure. We need to find the closure. To find the closure, I will give a simple trick, sir. Consider the first FD. What is the first FD? A implies BC. So what we do is we identify all the FDs. We identify all the FDs in which the left side is A. For that, what we need to do? Find the closure of A. What is the closure of A with respect to this one, sir? With A, we can get A. Because you are having A implies BC, you can have B as well as C. Anything else possible, sir? S. We have B implies D. So you can write D also. Anything else? Yes. With the CD, you can get E. So that means you can get this one also. So with the help of A, I can get all these attributes. So what you can write, sir? You can write A implies A. That we are not writing because it is trivial. The second one, A implies BC. This they were given, sir. Anyway, this is a valid FD. And A implies D. This is also valid FD. Then the next one is A implies E. So these are the valid FDs in which on LHS we have the attribute A, right? So let us do the same thing for second FD. What is the second FD, sir? The second FD is CD implies E. To get all the FDs in which the LHS is equal to CD, what we supposed to do, sir? We need to find the closure of CD. What is the closure of CD? With C comma D, I can get CD. Of course, we can get E. Why? Because we have a dependency. Sorry, sir. So we have a dependency. CD goes to E. Anything else possible, sir? With E, we can get D, but D already there. Then CD implies E, that was already there. Anyway, we got only these. So from this, CD implies CD, which is trivial. Forget about it. CD implies E. This they already given, sir. So that means we can have only one FD. On LHS, we have CD. Let us go to the third one. What is closure of B, sir? The same process. Let us do it. B, D. Anything else possible? I think no. Right? That means what are the FDs you can write with this? You can write only B implies D. Then what is the fourth step we are having, sir? The fourth FD we are having is E implies D. What is the closure of E? With E, I can get E. With E, I can get D. Then nothing is possible. So that means the only FD is E implies D. That's it. So these are the valid non-trivial FDs because we are not considering trivial FDs. Trivial FDs will always hold in any set of FDs. So that's why we are not considering trivial FDs. So what is the F closure? The F closure is, the first one is A implies BC. The second one is, sorry, I think it's A, right? So the second one is A implies D. The third one is A implies E. Then we have CD goes to E, right? Then we have B goes to D. Then we have E goes to D. So these are the 6 FDs we are having, right? So we completed the first step, right? What is the second step, sir? We need to separate the FDs of F into F1 comma F2. That means find F1 comma F2. So for that, what we need to do, sir? Consider the FDs which consists of the attributes of R1. What is R1? A, B, C, E. So write the FDs which consists of only these 4. A implies BC. Yes. Then A implies D. It is not valid, sir. On F1, on R1, right? So we don't consider it. Then A goes to E. Yes, you can write it. Then CD goes to E. D is not there. So this we don't consider. This we don't consider. B goes to D. This also we should not write it. E goes to D. D is not there. We should not write it. So these are the 2 FDs which consists of only the attributes R1. Hope this is clear, sir. We are writing the FDs which is having only A, B, C, E. If they are having anything else, we don't write it. That is F1. What is F2? Let me write R2. What is R2, sir? BD. So I need to write the FDs with BD only. I have only B comma D. So this is F1, F2. Then what is the third step? The third step is we need to make union of F1 comma F2. Let us continue in the next slide. What is F1, sir? F1 is A goes to BC, A goes to E. We have two FDs in F1. What is F2, sir? We have only one, that is B goes to D. Right? So we completed the second step. What is the third step? Find F1 union F2. What is F1 union F2, sir? Just make union of the given F1, F2. So you will get A goes to BC, A goes to E, B goes to D. Right? So this is our third step. What is the major step or the last step, sir? That is F1 union F2. Is it covering the given F or not? If it is covering all the FDs in F, that means we are preserving all the FDs of F. That is the intention of dependency preserving. Right? Then we need to verify whether all the FDs of F are valid or not. What is the first one, sir? First FD in F. FD1 in F. Let me write like this. A implies BC. It already present in union. So this is present in union. That means it was covered by union. Am I right, sir? So no need to verify it. Hope you understood it. What is the second FD, sir? The second FD in F is CD goes to E. If it is present in union, no issue. You can go to the next one. But please observe it. Here it is not present in union. Then what you need to do, sir? It is not present. So now I need to verify whether it was implied by F1 union F2 or not. What is the procedure, sir? Find the closure of CD plus. What is the closure of CD plus, sir? With C comma D, I can get CD, right? Then anything else possible, sir? Please verify it. With the C, I don't get anything, sir. With the C, I don't get anything. So this is the only story. That means with the CD, I can write only CD. When you are writing the closure, use only FDs of F1 union F2. While you are writing the closures, we need to consider only the FDs of F1 union F2. So that means this CD implies E is not implied by F1 union F2. Is not implied by F1 union F2. So what is our conclusion, sir? F1 union F2 not covering F. Since it is not covering F, the decomposition not satisfies, not dependency preserving. If it covers all the FDs, then we say it is dependency preserving. Hope you understood the process. Just go through it, sir. If you have any doubts, please raise in chat box. Yes. So let's go to the next. Let us consider one more example. Here again we have a relation with the 5 attributes A, B, C, D, E, and we have F with 3 FDs. A implies BC, C implies DE, D implies E, and R is divided into 2 relations. The first one contains A, B, C, D. The second one contains D. So let us continue the same procedure, sir. What is the procedure? The first one is we need to find the closure. For that, what should we do, sir? Consider the first FD. A implies BC. What is A closure? With A, you can get A, B, C. Anything else possible, sir? Yes. I have C implies D comma E. So I can get D comma E. That means the valid FDs with A is A implies BC. This the given, sir. A implies D. This we got it. A implies E. Right? So let us consider the second one. C implies D. Find the closure of C. What is the closure of C, sir? With the C, you can get C, D, E. Anything else possible? With the D, you can get E. That we retain. That's it. So you can write only C implies D. What is the third one? D implies E. What is D closure, sir? D closure is D, E. Anything else possible? No. That means the only FD with this is D implies E. That's it. So what is F closure? A implies BC, A implies D, A implies E. Then what we are having, sir? C implies DE, D implies E. Right? So this is F plus or F closure. We completed the first step. What is the second step? Find F1 comma F2. For that, first we need to consider the attributes of R1. What is R1? A, B, C, D. Write the FDs which consists of only these 4. A implies BC, it's fine. A implies D, it's fine. A implies E, this we should not write because A is not here. Then C implies D, E, this also we don't write it. D implies E, this also we don't write on F1. So in F1, I have only 2. A implies BC, A implies D. Then what about R2? I have only D comma E. What are the FDs, sir? I have only FD D comma, D implies E. This is my F2. Right, sir? What is the third step, sir? The third step is let us make union of these two. F1 union F2. What is F1 union F2, sir? A implies BC, A implies D, D implies E. So we completed the third step. What is the next step, sir? we need to verify whether this union covers the given F or not, right? So in F1 union F2, we have three FDs. A implies BC, A implies D, D implies E. Let us continue the third step. What is the third step, sir? Let us verify F1 union F2 covers F or not. So for that, we need to assume the FDs in F1 union F2. Assume FDs in F1 union F2 are valid. That is the procedure we have done in equivalence concept. What are the F1 union F2, sir? Hope you remember it. A implies BC. A implies D. D implies E. Right? We need to verify. We need to verify FDs of F are valid or not. That means whether they were implied by F1 union F2 or not. So let us consider one by one. What is the first FD in F? The first FD is A implies BC. If you observe clearly, A implies BC is present in union. So no need to verify it because it was already there. Present in union. So it is valid. Let's go to the second FD. What is second FD, sir? The second FD is A implies D. Yeah. I think this is not present in union, sir. Not present in union, right? Then let us find the procedure. A closure. What is A closure? Sir, this is the main step we need to keep in mind. When we find the closure, we need to use the FDs of F1 union F2 only. So with A, I can get A. Anything else possible, sir? I have a dependency A implies BC in union. So I can get B comma C. Then I have A implies sorry, sir. Actually, we done something wrong. Yeah. What is the second FD in F, sir? That is C implies D. I'm sorry for it. Actually, I have written that one. So, right, fine. So let us consider from second FD. What is second FD, sir? Second FD in F is C implies D. Is it present in F1 union F2, sir? No, it is not present. It is not present in union. So what should we do, sir? We need to find the closure. To find the closure, we need to use FDs of F only. So with the C, I can get C. Anything else possible, sir? With the C, anything else possible, sir? Sir, I think we have done something wrong for this problem, sir. Let us do it again. I'm sorry for it. So I will explain where we have done the wrong, sir. Just now I observed it. Fine. This is the problem we have done, right? So now the main wrong what we have done is in finding F1 union F2 we have done wrong, sir. Extremely sorry. Fine. So what is the second step, sir? The second step is we need to find F1 comma F2. How to form F1, sir? We need to consider the attributes of R1 only. A, B, C, D. So the first one, A implies BC is valid, sir. A implies D, it is also valid. A implies E, it is not valid, sir. Now let us consider the third one. C implies D. Sir, C implies DE can be written C implies D as well as C implies E. Because the right side we can decompose using the decomposition rule. So C implies D, we have only the attributes of R1, right? Then D implies E. E I don't have, sir. So this is our F1. Then what about F2, sir? In R2 we have D comma E. So in F2 we have only D implies E. Sir, please keep these type of FDs in mind, sir. C implies DE. E is not present, but C can imply D, right? So that we need to consider in F1. What is the third step, sir? The third step is we need to find union. We need to find union. A implies BC, A implies D, C implies D, D implies E. So this is union. What is our fourth step, sir? We need to verify whether this union covers F or not. Let us verify F1 union F2 covers F or not. For that, what we need to do? First, we will assume FDs of F1 union F2 are valid. What are the FDs of F1 union F2, sir? A goes to BC, C goes to D. Then what else, sir? A goes to D, D goes to E. These are the FDs in F. What we need to verify? We need to verify FDs of F are valid or not. So what is the first FD, sir? FD1 in F. What is FD1? A implies BC. Please observe it. This is directly present in union. So no need to verify whether it was implied or not because it is already present. That means it is a valid. Present in union. It is valid. What is the second FD, sir? The second FD is C implies DE. If you observe it, it is not present in union. It is not present in union. So let us find the closure of LHS. What is the closure of LHS, sir? To find the closure, we need to use the FDs of union only. Please keep this point in mind, right? So with the C, I can get C. Anything else? With the C, I can get D. Then with the D, I can get E. Anything else possible, sir? No. So the closure contains this one. Now the question is, since with the C you can get D comma E, can I say this is valid or not? Yes, this is valid. Am I right, sir? So the second FD is valid. What about the third one, sir? FD3 in F. What is it? D implies E. It is directly present in union, sir. Present in union. Right? So all were implied. You can say F1 union F2 covers F. So what is your conclusion, sir? It is a dependency preserving decomposition, because we are preserving all the FDs of F, preserving. Okay, just go through it, sir. If you have any doubts, please raise in chat box. Hope you understood it. So this is about the second property, dependency preserving decomposition. Now the question is, in these two examples, the relation is divided into two parts, R1 comma R2. Then suppose the relation is divided into three parts. What is the procedure? The same procedure, sir. Whenever the relation is divided into two relations, what you done? You calculated F1, F2. Now it is three parts. So find F1, F2, F3. That's it. What is the main step we need to verify? We need to find the union of these three, and we need to verify whether it covers F or not. So the same procedure, but instead of having F1 comma F2, this time we will have F1, F2, F3. That's it. So let me explain the same procedure with this example. What is the first step, sir? The first step is we have done so many times. So let us do it quickly. Find F plus. So what is the first one? AB implies CD. Then with AB, what else you can get? AB closer. AB, right? Then AB implies CD. This already we have, sir. So let me write ABCD. Then with the D, you can get E. So we got all the five attributes. So AB implies CD. So better to write separately, sir. AB implies C, AB implies D. If we have only one attribute on RHS, then it will be easy for us to write clearly F1 union F2. Then AB implies E. We are not writing AB implies AB because it is trivial. So what is the second FD? The second FD is D goes to A. With the D goes to A, what else possible, sir? D closer equal to D comma A. Then anything else possible, sir? With the D, A, yeah. With the D, I can get E. Then with the E, with the D, you can get A. That we already written, sir. That's it, I think. So we got D implies A. D implies E. Right? That is with second FD. What is third FD, sir? C implies D. So C closer. With the C, you can get C, D. Then with the C, you can get E also. Right? Then With D, you can get A also, right? So what you can write from this, sir? Let me write it here. C implies D, C implies E, C implies A. What is the fourth one, sir? C implies E. Sir, with the C, we already written all the valid FDs. So no need to consider it, right? So let us consider the next one. D implies E. What is D closer? D closer is D okay, E okay. Anything else possible? Yes, with the D, we can get A. Then that's it. So what are the valid FDs? D implies E, D implies A. Fine. So we completed the main task, that is finding the closer. So now let me write F closer. What is F closer, sir? Let us write all the FDs. AB implies C, AB implies D, AB implies E, right? The second one is D implies A, D implies E, then C implies D, C implies E, C implies A. Then we already completed with the D plus, right? Again we have written. So it is also not needed, sir. I have not observed this one. So no need to consider it because we already completed D goes to E. Even if you consider it, no issue, sir. It will take some time, that's it. So we already completed with D. So we will have only up to here. Fine. What is the second step, sir? The second step is find F1, F2, F3, right? So the first step is F1. What is R1, sir? A, B, C. So you can list out what is F1. They should consist of only A, B, C. A implies C. Then C. Anything else, sir? C implies A. What about R2? R2 is B, C, D. So what is F2? B, C, D. B, C, D. B, C, D. You can write C implies D. Anything else possible, sir? B, C, D. That's it. What about R3? A, D, E. A, D, E. A, D, E. D implies A, D implies E. Then here I have C, here I have C, here I have C. Leave it. Hope you written very well, sir. Please check it again. The first one ABC. AB implies C. This we should not write. AB implies C. We should not write. D, D. We should not write. C implies D. Leave it. C implies A. We written. Then B, C, D. B, C, D. So B, C, D. C implies D. That's it. Then the last one A, D, E. A, D, E. So we have D goes to E, D goes to A. That's it. So in next step, what we need to do, sir? We need to find the union. So let me write in next slide. find F1 union F2 union F3. Okay, so let me write it, sir. AB implies C, C implies A. AB implies C, C implies A. AB implies C, C implies A. What is F2? C goes to D. Fine. Then next one, sir. D goes to A, D goes to E. D goes to A, D goes to E. Right. So let us continue the fourth step. Verify this covers F or not. Verify this union covers F or not. Right. So what is the first FD, sir? FD1 in F. Let me write it. So what is it? AB implies CD. Is it directly present in union, sir? No. So let us write AB closer. With AB, you can get AB. I have a dependency, AB implies C. So I will get C. Then I have a dependency, C goes to D. So you can get D. Then I have a dependency, D goes to E. Right? So what does it mean? You can write AB implies CD. This is what we need to verify, right? So this is valid. What is second one, sir? FD2. D goes to A. D goes to A. Sir, please observe it. I think D goes to A is present. It is directly present. What is FD3? FD3 is C goes to D. I think this also present, sir. Please check it. So C goes to D. What is FD4? C goes to E. C goes to E. It's not there, sir. So let us do the process. What is C closer? With the C, I can get C. Anything else possible, sir? S. C goes to A. With C, I can get D. With D, I can get E. That's it. Now the question is, can we say this is valid? Yes. With the C, you can get all these attributes. So this is valid. What is the next one, sir? The last FD is D implies E. D implies E is directly present, right? So what is our conclusion? This union covers all the FDs. F. So it is dependency preserving. That means this decomposition satisfies dependency preserving property. Hope I understood it. Similarly, you can do even the relation is decomposed into 4 relations or 5 relations. The only step is we need to identify the corresponding F1, F2, F3, F4 like that, right? So let us do some previous questions on both properties, lossless as well as dependency preserving. So just go through the questions, sir. For the relation R, what are the attributes? L, M, N, O, P. Fine. And the FDs are M implies O, NO implies P, P implies L, and L implies Mn. Let me write it here. Fine. Then R is decomposed into R1, LMNP, R2, MO. And we need to verify it satisfies which of the properties. Let us do the first property. What is the first property, sir? lossless. So to verify the lossless, what is R1 here? They given L, M, N, P. What is R2? MO. What is the second step, sir? R1 intersection R2. What is intersection? I think I have only M. Then the third one is we need to verify whether it is a key or not. To verify a key or not, what we supposed to do, sir? M closer. If you want to know the procedure of lossless property verification, please go through the last session. So M closer is with M, I can get M. Anything else with M, I can get O. Then with M, I can get this one, right? Then anything else possible, sir? No. Fine. So that means I have only MO. Anyway, this contains R2. Sir, contains R2 in the sense contains all the attributes of R2. That is my intention. So this M is a key for R2. So you can say, okay, let me write it here. R1 intersection R2 is a key for R2. So what is our conclusion, sir? Therefore, it is lossless. Therefore, it is lossless. Hope you understood it. So now the second step. What is the second step, sir? We need to verify whether it is dependency preserving or not. Let us do it. Find F closer. Let us assume this is F. F closer we need to do, sir. Right? Okay, let me write like this. First, we are finding the closer. Okay. What is the first one? M goes to O. What is M closer, sir? M comma O. Anything else possible? No, sir. So that means I can get only M goes to O. What is the second FD, sir? The second FD is NO goes to P. So with NO closer, what you can get? NO okay, P okay. With P you can get L. Yes. With L you can get MN. Then L, M, N, O, P. I think we got all the things. So what are the valid FDs, sir? You can write NO implies P, NO implies L, NO implies M. Right? What is the third FD, sir? P goes to L. What is P closer? With the P you can get PL. With L you can get MN. Then with M you can get O. Let me write MN. Then I can get O. Am I right? So that means I can write P implies L, P implies M, P implies N, P implies O. Fine. Then what is the third one? The third one is L implies MN. What is L closer? L, M, N. Then with M you can get O. Then with NO you can get P. Right? So you are able to get L implies M, L implies N, L implies O, L implies P. That's it. So let us write the closure. What is the closure, sir? F closure equal to M goes to O, NO goes to P, NO goes to L, NO goes to M. P goes to L, P goes to M, P goes to N, P goes to O. Then L implies M, L implies N, L implies O, L implies P. So we completed the major step. What is the second step, sir? The second step is F1. To find F1, what is R1, sir? L, M, N, P. Right? So I think better to write like this. R1 is L, M, N, P. What is F1, sir? Write the FDs which consists of only these four. M goes to O, I should not write. NO, I should not write. NO, I should not write. P goes to L, I can write. P goes to M, P goes to N, P goes to O, we should not write. Then L goes to M, L goes to N, L goes to P. What is R2, sir? MO. We need to write the FDs of only MO. With only MO, what you have? M goes to O, okay. Anything else? No, sir. That's it. What is the third step? F1 union F2. What you are having, sir? You are having P goes to L, P goes to M, P goes to N. Then L goes to M, L goes to N, L goes to P, M goes to O. What is the fourth step, sir? We need to verify whether it covers F or not. What is the first FD, sir? FD1 in F. M goes to O. Please observe it. It is directly present in the union. What is FD2? NO implies P, but it was not there. So let us find the closure. What is NO closure? What is NO closure, sir? Please check it. NO closure. I think we will get only NO. Anything else possible? No, sir. So this is not valid. This is not valid. Am I clear, sir? So what is our conclusion? This one not covers F. So it not dependency preserving. Please go through it, sir. If you have any doubts, please raise in chat box. Fine. So what is the answer for this question, sir? It is lossless, yes, and it is not dependency preserving. It is lossless and it is not dependency preserving. Hope you understood it. Let us do one more question on these properties. Yeah. Let R is a relation with 4 attributes A, B, C, D. And the functional dependencies are A implies B, B implies C, C implies D, D implies B. 4, right? So we need to verify whether it is a lossless and dependency preserving, right? So first let us verify lossless property. What is R1? Okay, let us assume they are not given any names, sir. Let us assume the first one is R1. The second one is R2. The third one is R3. So what is the first step, sir? Find the common attributes of all the three. R1 intersection, R2 intersection, R3. What is it? B. What is the third step? Find the closure. What is B closure? With B you can get B. Anything else possible, sir? B implies C. Then I have C implies D. Then that's it. Right? Now, is it containing all the attributes of R2? Yes, sir. R1 is not there. So you can say B plus contains R2 as well as R3 also. So what is your conclusion, sir? B is a key for R2 as well as R3 also. One is enough, sir, but we have two. So it is classless. This is the first property we need to verify. What is the second property, sir? Dependency preserving we need to verify. Right? So to verify dependency preserving, let me name it as R1, R2, R3. First we need to find the closure, sir. Find F closure. For that, let us consider the first one, A implies B. With A implies B, that means with A, what you can write? A, B, with B, I have C. With C, you have D. So you can write all, sir. That means A implies B is valid. A implies C is valid. A implies D is valid. Fine. What is the second one? B implies C. What is the closure of B, sir? That is B. Fine. Then with the B you can get C. Yes. With the C you can get D. Yes. Anything else? No. So you can write B implies C, B implies D. What about third one? That is C goes to D. C closure. C, D. Then with the D you can get B. So you can write C implies D, C implies B. What is the fourth one? D implies B. With the D, what you can write? With the D, you can write D comma B. With the B, you can write C. That's it. So we are having D implies B, D implies C. So with the first A, you can write 3. With the B, you can write 2. With the C, you can write 2. With the D, you can write 2. Right? So what is the second step? Okay, first let me conclude the first step. That is the closure. In closure, we need to write all the valid FDs. A implies B, A implies C, A implies D. Then B implies C, B implies D. C implies D also, C implies B also, D implies B, D implies C. Right. So we completed the first step. What is the second step, sir? The second step is we need to find F1, F2, F3. So what is R1 AB? What is F1? A implies B. Anything else possible, sir? No. What is R2? BC. With BC, B implies C, C implies B. What is R3? B, D. With BD, you can write B implies D, B implies B. Right? So this we completed, sir. Now the third step. What is the third step? Make union and verify whether it covers F or not. F1 union, F2 union, F3. A implies B, B implies C, C implies B, B implies D, D implies B. Verify the fourth step. What is the fourth step, sir? F1 union, F2 union, F3 covers F or not. What is the first FD in F1, sir? Sorry, what is the first FD in F? A implies B. Please observe it. It is present in the union. What is the second one? Let me write it here. B implies C. It is also present, sir. What about third one? Sir, A implies B is there, B implies C is there. What is the third one? C implies D. C implies D, C implies D is not there, sir. So let us find the closure. What is C closure? C you can write, sir. Then anything else? With the C you can get B. With the D you can get thing. Then let us do one thing. B I don't have, right? So with the B you can get D. So you can get C, B, D. So we got D, sir. Please observe it. With the C you are able to get D. So this is valid. It was not directly present, but it is valid. Then what about fourth FD, sir? D implies B. I think it is present directly. So what is your conclusion? F1 union F2 union F3 covers all the FDs of F. Therefore, it is dependency preserving. Dependency preserving. So this decomposition satisfies both properties, lossless as well as dependency preserving. So what is the answer for this question, sir? It gives a lossless join and it is dependency preserving. Hope you understood it. So that is about the properties of decomposition. Hope you understood each and everything. In the next session, we will discuss normal forms, which is very, very important in normalization concept. Thank you.